Welcome, students. It's Mr. Thayer, and today we're going to be finishing up the How Can I Make Predictions worksheet and then giving you some examples and help and time to work on today's Line of Best Fit worksheet. So let's take a look. So you measured your foot length and your height, and then you gathered some data from your peers. Now I'm going to use sample data. Remember, it's not yours. It should be somewhat similar, but you came up with your own line of best fit based off of your table. So here's a scatter plot we came up with. Notice the y-axis is the height in inches and the x-axis is the foot length in inches. We've selected 2 points, and these 2 points make our line of best fit, which is great because the line passes through the middle of the data. That's what we need. But now we need to take these 2 points and get an equation. So remember 863 and 1071. So here we are taking our 2 points. We'll come back to part 4 in a moment. And we want to get our slope and we want to get our y-intercept. Those are the 2 pieces we need to get an equation in slope-intercept form. Pause this video and find your slope and y-intercept if you haven't already done so. Once you've had some time to try it on your own, let's check our answers. Based off of your points, remember, not mine. Mine are just an example. So my slope can be found by taking the change in y divided by the change in x, which comes out to 8/2, or just 4. Now the y-intercept can be found by plugging in our slope and one of these coordinates for x and for y. So I'm going to plug in 71 for y and 10 for x, but you could plug in either one of your coordinates. That'll give me 71 equals 40 plus b. So we can already see b is going to end up being 31 here in just a moment, but we can subtract on both sides to finish this. So our equation for our prediction would be 4x plus 31, where x represents the foot length and y represents your height, both measured in inches. As we head back to part 4, we're going to explore how can we describe the association of a scatter plot. Well, we have our choices in parentheses right next to each form, direction, outliers, and strength. So form means, is it curved? Is it somewhat straight? Is it completely scattered? And our scatter plot here is somewhat following a straight line. So we're going to choose linear for our first choice. The direction, positive means flowing upwards from left to right. Negative means flowing downwards. So positive is your points are going up versus negative, our points are going down as you read it. And ours is clearly going up, so it's positive. Outliers, I like to think of a herd of sheep. The sheep are going in one direction except for maybe one lost sheep. We don't appear to have any single lost data point or sheep like hanging out over here. So there are no outliers here, and that can sometimes be the case. So none. And the strength. Is this graph strong, moderately weak, or weak? That's really saying, is your data very much in a line? Is it somewhat in a line? Is it flowing upwards, but not at all really in a line? Or is it completely randomized? I think we would select here that this is moderately strong based off of the flow of our data. But we'll come up with the correlation coefficient for more exact measurement later on in this chapter. Okay, so we've got our equation. We've got our association described. So let's take that equation, y equals 4x plus 31, and let's apply it to make predictions. So predictions that are within our data is called interpolating. Predictions that are outside of our data are called extrapolating. First, let's discuss what the slope means. Remember, slope is change in y, and y is height. So 4 inches is referring to our height. And x is our foot length. So if we say this out loud, we would say something like, a person's height is increasing 4 inches for every 1 inch in foot length. And we would just write that as a sentence. The y-intercept is where we begin. Sometimes the y-intercept makes sense, sometimes it doesn't. Remember, this is for your statistical model to make predictions. So the y-intercept doesn't always make sense in context. Does it make sense here that someone could have a foot size of 0 and a height of 31 inches? No, it definitely doesn't. So not in context, or doesn't make sense in context, and that's okay. But again, as we go back over here, a person is gaining 4 inches in height for every 1 inch foot length. All right, let's go make some predictions now. Now this 10 right here is inside of our data, so that's called interpolating or interpolate. But this Shaq's shoe size of 16.1 is well outside of our data. That's called extrapolate. So we'll take our equation of y equals 4x plus 1, or 31 rather, and we'll take this 10 inches in shoe size or foot length, and that's our x variable. So we'll plug it in for x, and we'll interpolate, we'll predict inside of our data how tall we would expect this person to be, and we already know where this is going. This person's going to be about 71 inches tall. Going over here on the right side, we have a prediction beyond what our data shows on our scatter plot. Again, it's going in for x though. So we'll hop on the calculator and do 4 times 16.1. And we'll add 31 to that to get 95.4. So we would expect someone with a shoe size or foot size of 16.1 to be 95.4 inches tall in height. All right, next video will show us how to get started on our following worksheet, where you can apply this knowledge to that in 2 different example problems.